Last one, C. Again, we're going to begin by factoring. Factoring helps us locate our zeros, our asymptotes, our wholes, all of that together. So we have an x minus 3 and an x plus a 3 on the top and an x plus a 4 on the bottom. So if I want horizontal asymptotes, I will look for dominant terms as x goes to positive infinity or negative infinity. Again, no absolute values, exponentials, so dominant on the right is going to be the same as dominant on the left. I end up with x, which means I have no horizontal asymptote, because that limit, as x gets bigger and bigger and bigger, sorry I dropped my limit, is going to be infinity. It also tells you that the graph of this, if you go out far enough, eventually it's going to kind of behave like y equals x. That's a little beyond what we did already, but I'll stick it on there just to illustrate. This is not going to show up on the test with this format. I would just look for a none. Okay, next we have the vertical asymptotes. Remember, those are problems that create zeros in the bottom that are not zeros on the top. So that's going to occur when x equals negative 4. So I can look at negative 4 here is my vertical asymptote. The next thing I'd look for is my hole. Well, holes occur when I've got zeros in the bottom that are echoed in the top. Well, I don't have any zeros in the top that are also in the bottom, so I'll put a none. X-intercepts occur when the top of the fraction equals 0 and it's in the domain. So we got a 3 and a negative 3. Both of those are in the domain, so I'm going to have 2 zeros at a 3, 0, and a negative 3, 0. So I can go plot those on my graph. The next thing I can do is the y-intercept. That means I plug in an x equals 0. If I plug in an x equals 0, I get a negative 9 over 4. So again, I can plot that on my graph. Negative 9/4, we're about here. Then I want to connect. So if I connect, I know that I can't cross the x-axis other than at these 2 points, and my options are to do something like this, which seems a little unlikely. So to verify, I'm going to get close to that negative 4 from the right-hand side. If I come down here and look, plugging in a number a little bit bigger than 4, this will be positive, this will be positive, and this will be positive. So that means as I approach negative 4 from the right side, I'm going to be heading up. Then once I cross, I have to come down to hit this point, and then I'm going to go back up to hit this point, and I will get closer and closer and closer to that y equals x behavior. Now, if you graph this on your calculator, which is not allowed, you will see that you get a little bit of curve down in this area. So on a problem of this sort, I wouldn't expect you to locate that. In fact, I think it ends up being off the screen. We could check by plugging in a negative 6. If I plug in a negative 6, I have a 36 minus 9 over a negative 2, so it's a negative number kind of down here, and we would get that.